Dynamic load testing offers a cost-effective means to evaluate the capacity of drilled shafts, auger cast-in-place piles, helical piles, micropiles, driven piles, and other deep foundation elements. It can be performed on a percentage of production foundations as part of a routine quality control program or as needed to assist in assessing a selected foundation. Dynamic load tests can also be performed on test elements that are cast with embedded strain gauges for additional load transfer insight and final design. Key components of a dynamic load test include a suitably sized ram, a guide frame, a controllable drop height with free release, a PDA DLT system for acquiring and processing strain and acceleration measurements, quality, force and velocity records, accurate foundation movement records, and CapWAP software and experience analysis personnel. In soil, a minimum ram weight of 2% of the required ultimate capacity is recommended, while in rock, a minimum ram weight of 1% of the required ultimate capacity is recommended. Various GRL Apple systems are available to suit project needs, with ram weights ranging from 1 ton to 80 tons. Prior to testing, the top surface should be level with any weak concrete or grout removed. A thin plywood cushion is then placed atop the foundation top surface. A top transducer, instrumented with strain gauges, is used to determine the force applied to the foundation. The top transducer is typically attached to the foundation using anchors. The segmental drop weight ram is assembled on a firm surface. Segmental weights are positioned over the lift post and atop the initial piece to assemble the drop system ram. The guide frame is positioned around the ram weights. Steel plates and a plywood cushion are placed atop the top transducer. The crane lifts the assembled ram and guide frame and positions them atop the top transducer. Accelerometers are attached to the foundation, and all the instrumentation is connected to a pile driving analyzer using DLT software. The main crane line is attached to the lift post and the ram is raised to the desired drop height. The hydraulic jack atop the frame is then pressurized, locking onto the lift post. With the jack locked, the main crane line is lowered. This removes the drop weight load from the crane line and transfers the load to the guide frame and the ground. The crane's second line, attached to the guide frame, is also lowered. The pressure on the hydraulic jack is released, allowing the ram to fall and impact the top transducer. The PDA DLT processes the strain and acceleration measurements and displays the force and velocity record from the impact event. The foundation movement from the blow is measured and recorded. Based on the movement, recorded stress levels, and mobilized capacity, the process is typically repeated at increasingly higher drop heights, with the incremental and cumulative movement recorded after each blow. A total of 3 to 5 blows are typically applied. The test is terminated once the required capacity is mobilized, maximum acceptable stress levels are reached, or if excessive foundation movement is recorded. GRL engineers gather the available project information and assemble the dynamic load test field data. With the background knowledge provided by the assembled project and test data, a CapWAP analysis is performed on select dynamic load test records to assess load capacity. Dynamic load test details and CapWAP analysis results are summarized in the dynamic load test report. To learn more about dynamic load testing with the Apple systems, visit grlengineers.com.